Well, hello, Team C++. Today we are going to start a new video, and in this video we're going to talk about, not looping, we're going to talk about if statement and selection structures. Now, I'm going to organize this video in multiple sections. First of all, we're going to talk about why do we need selection structures, and what are the basics of selection structures? What are the Boolean expressions, and how do we create Boolean expressions, and what is the meaning of Boolean expressions? How do we evaluate Boolean expressions? What does short circuit means in Boolean expression? And then we're going to talk about the enum data type. And then after that, we're going to talk about the types of selection structures, which basically we have three of them in C++. We have if, we have if-else, and we have switch. And we're going to take each one of those structures and we're going to talk about them. We're going to see where do they work, where do they not work, what are the syntax, and we'll see if we have some examples, if we have time for some examples. Also, we're going to talk about the scope of variables whenever you have a block of code in your project. Now, first thing we need to talk about is basically what is selection structure and why do we need it, and if there are any real-life applications to make it easier to understand what it is. So let me start with what is a selection structure. Well, basically, a selection structure or selection structures are tools that you have in C++ or any other programming languages, and it helps you make decisions. That's basically what selection structure is. You can use selection structures in your program so your program can make decisions, and this is a very, very important concept in programming. Take artificial intelligence, for example, robotic, for example. In a lot of cases, it's all about making decisions. So how can I make a computer make a decision? I'll give you an example. I studied medical imaging for a really long time, and we basically got to a point where we can have a software that can get the job of the doctor done. Basically, in my field, for example, I used to feed my program around 300 images, CAT scan images, and then after that the program will study those images, and then it will bring my attention to the size of the liver, for example, and if there is any diffused fat inside the liver and how much is that diffused fat, and if I should be concerned about that amount or not, or that person has a fatty liver or not. And I didn't continue in that process because the whole point or the goal was to be able to find tumor inside a liver. But I stopped at a point of just evaluating how healthy the liver is. Now, basically, my program was able to do that. The program basically was extracting the liver out of all these 300 CAT images and building a 3D module and estimate the size of it, and after that studying how much diffuse fat is inside that liver using that 3D model that it created. Now again, how is that possible? How can the program tell this is the heart, or this is the liver, or this is the lung, or this is the kidney, or this is the bones, or all these other tissues? Well, that's where the selection structure plays a major role here. The selection structure basically will take and study each pixel individually in those images, and also study the relation between the neighbor pixels in those images, and based on certain criteria, the program was able to classify a pixel to be a liver pixel or a non-liver pixel. That's just an application. Now think about computer vision applications. Think about the cars these days. How new cars, if you get closer to another car in front of you, your car automatically will stop. How did the car make that decision? Well, basically there's a selection structure inside that computer that controls that car that take that decision, and that decision was basically made based on a measurement from your car and the front car, and since that distance gets really, really smaller or close, those cars get closer, that's where the car decides, this is more time for me to stop. So I can go for hours just talking about applications that's built on selection, and I will tell you, like, computers of these days are basically built based on these selection structures. Artificial intelligence, machine learning, computer vision, and I can go on and on. Now, you are a little bit earlier, it's too early for you to get into those type of applications, but you will be dealing with, let's say, searching or sorting algorithms, which basically you would need to use a selection structure. For example, if I'm searching for an element in a data structure or a database, and let's say we have millions of records in that data structure, how does this search work? Well, basically, you're going to go record by record until you're looking for a match. The moment you find a match, retrieve the data from that record. And that's basically, again, an example of a selection structure. So, with that being said, let's jump into the basics of selection structure. Well, selection structures in a programming language are built based on Boolean expressions. Now, you may ask, what is a Boolean expression? Well, a Boolean expression is a statement or an expression that will evaluate it by the compiler to return a true or a false value. For example, let's look here. I'm going to put a cout just to show you what is a Boolean expression. And I'm going to put in parentheses, and let's just put end line here. And of course, I need to using std end line. So let's go ahead and add that here. ENDL. Okay, so go away. Now, look at this. 10 is greater than 5. Now, this is here, it's a Boolean expression. I am comparing the value of 10 with the value of 5, and I'm asking the question, is this expression is true or false? Well, of course, it's true. Now, in C++, anything that is true is interpreted to 1. Anything that's false is interpreted to 0. So if I run it, and of course, this is me doing it for the first time, so we're going to have to wait a little bit. Come on. I'm going to go make a sandwich and come back. I'm just kidding. Actually, I may be able to make a sandwich and come back and still working. I'll see if I can fast forward this. I don't think so. Okay, lovely. Let me just increase the font size. And here we go. So it's 1. Let me press enter. And let me go back here and change this to equal instead of greater than. Now I'm going to talk about those operations later. I think I mentioned them before, but let's just keep going. It should be faster, and you can see here I got a 0. Okay, so as you can see here, this is a Boolean expression. The compiler was able to evaluate the expression and then return a true or false based on the final results of the evaluation. Now, before we start getting into the details, we need to understand, or we need to talk about how many different comparison operations that we have. And I'm going to list them here. We have basically equal, we have not equal, we have greater than, we have greater than equal, and you have less than, we have less than equal. Let me see if I'm missing anything. No, I don't think I'm missing anything. So those are the basic comparison operations. One thing that you need to be worried about, or aware of, this is not this. This is assignment operation. This is a comparison equal operation. Now, why am I saying this? Why do I put this? It's obviously easy to understand, but let me tell you something. You'll make that mistake. You'll write a code for 10 pages and 20 pages, and because you were just trying to do it really, really fast, you will miss and forget to type double equals instead of a single equal. And guess what? The compiler will take it and accept it, and there will be no problems. But the results are not going to be as you think it should be. You will get some logical errors. So always pay attention. Whenever you want to compare two values, you need to use a double equal. And if you want to assign a variable or a value to a value, use a single value. So this is something to put under consideration. Now let's go ahead and try to create variables just to give them a test. Integer num1 equal 90, and then integer, or let me just go back here, num2 equal 87. Now I can come here and type num1 double equal num2. Remember, I'm trying to compare those two variables. Now, as you can see, he's complaining about this, and this is because basically the compilers get confused. Am I supposed to do this and then do this, or what exactly I'm supposed to do? So it's a good idea to us as programmers to tell the compiler which need to be done first. So evaluate the expression and then get anything else done. Now, this is of course going to be false. I'll get a 0. And here we go. Now, this is something I want you to do. I want you to go ahead and search in C++. How do I print false instead of 0 or true instead of 1 in C++? There is a statement that you can type in this area before, sorry, not this area, in this area here. I don't remember exactly what it is, but there is a statement or a function that you can call here, or let's say a tool you can type here that will basically evaluate the Boolean expression, and instead of printing it as 1 or 0, it printed as true and false. I want you to look for that, and if you find the solution, please type it as a comment. Okay, so this is Boolean expressions. This is how we do the comparison. This is very, very important to understand what is the meaning of all these operations. I'm going to provide you with an example by the time I'm done with the syntax and explanation of the concepts later. Okay, so this is basically what we mean by Boolean expressions. Now, Boolean expressions could be a little bit more complicated than just comparing two numbers. Now, before I go to the complication version, let me just talk about what kind of variables I should use whenever I go and use Boolean expressions. Well, there are no rules to be specific if you want to do that. Usually, again, I think I mentioned that before. We have what we call primitive data types, and we have non-primitive data types. If it's a non-primitive data type, then you need to really do your research before you start using those comparison operations to know how exactly that's going to be done. Non-primitive data type, for example, you have a variable that is a car and another variable that is a car. How do I compare two cars? Again, this is object-oriented programming, which is something you're going to be learning in the future, but I'm just telling you. If it's a primitive data type, then yes, I can do that. For example, integer, I can compare integers. Character with character, I can compare characters. Boolean with Boolean, I can compare Booleans. But again, we have some problems when it comes to floats and doubles. Now, why is that a problem? Because the precision makes a major role in the comparison. Sometimes when you type this, let me just tell you here, 0, what is this number? Well, it is 1. But guess what? Some other, this 1.00, when it's going to be stored inside the computer, it's basically going to be stored something like that. Even though you see this 9 here, it doesn't have any significant effect on the total value, but it is going to be there. And sometimes you have another variable, which is again 1.00. But again, when it's going to be stored inside the computer, it could be stored in the form of this. Now, you don't see that. You just see 1.00, 1.00. When you start comparing them, you think, oh, both of them are doubles or floats, and they should be the same, and then you get them not to equal the same because of this 9 and because of this 0. So it's not recommended at all to compare floats and doubles because of the precision of those values. But you can compare integers with integers, characters with characters. That will work. You can also compare integers with characters, and we're going to have examples of that later on. But at this level, let's just keep it integer with integer, character with character, and keep it that simple. Okay, now let's move on to a little bit more complicated Boolean expressions. And I am going to show you one thing here, and you have to understand this. What if I multiply this by 10, and I added, let's say, 903. Well, you know what? Let me just make it 19. Oh, look at this. A little bit more complicated. I'm including some arithmetic operations here, and I have the comparison operation. Now the compiler, you have to ask yourself, how the compiler will act for something like that. Well, here's the deal. Whenever you have a combination between a comparison operation and arithmetic operations, the compiler basically will do the following. Get all the arithmetic calculations done, and then perform the comparison operation. Now, I'm guessing this is going to be true because this is 9 multiplied by 10, so it's going to be 900, and this is 800. 813, and I think if you add it to this number, it should be 900. So let's run it, and hopefully I'm not calculating this. Oh yes, true. So here we go. So this is a fact that you should know, and again, I can actually come here and let's say add 1 to this. 1 plus, and then I can come here and put it as greater than, and it's still going to be true because now this is a 901. And here we go. Okay, so this is a Boolean expression that's a little bit more complicated than the first one that I started with. Okay, now, is that it? Is this the end of complication Boolean expressions? No. Well, basically, in addition to those comparison operations, we have what we call logical operations. So, what are the logical operations? Well, basically, we have 3 of them. We have the and we have the or, and we have the not. Now, what are those Boolean or logical operations? Well, the and and the or are used to connect 2 different simple Boolean expressions. The not is used to reverse the result of a Boolean expression. What does that mean? Well, let's go ahead and try them out one by one. I'm going to start with the not. So if I come here and say cout, where is it? And I'm going to say 10 equal 10. And I'll put end line here. Now, what do you think the 10 equal 10 expression, evaluation for this expression is going to be? Well, it's going to be true because 10 actually does equal 10. If I come here and put not, it's basically going to reverse whatever the result of the comparison here. Let me put it here. And here it is. It's a 0. Okay. How do I make this one obvious? Let me just tell you something. Even though you do have this tool to reverse the result of a Boolean expression, it's never recommended to use it. You use it only when you have no other choices. Why is it not recommended to use it? Because it's just going to get everyone confused when they're going to see it. 10 equal 10 not. So in a lot of cases, when you're going to write a Boolean expression, whoever's going to read it needs to understand what is the point of this comparison, or what is the point of doing this or creating this Boolean expression. So whenever you use the not, basically it adds a little bit level of confusion for people trying to understand what it is. What I can do here, if I want to get the results correctly, and this basically will be, I can read it as 10 equal 10 not. But wouldn't that be a lot easier if I just said 10 doesn't equal 10? That makes a lot more sense. So even though we do have this tool here, but it's not recommended to use it at all. Just like, no, I don't want to use that example because I want to do it. Like, you can eat all the French fries in the world, but is that recommended? No. You get diseases. Again, this is the same thing. You have the tool, it's available for you, but do not use it unless you have to. You have no other options. So this is a case here that will give you false. Now, what are the and the or? Well, basically, we use and to connect 2 Boolean expressions. So let's go back here and create another 2 Boolean expressions. I'm going to call this one 3 and this one 4. And as I said, right after I'm done with the whole what they call the whole syntax explanation and the background, I will have a project, a simple project, where I'm going to show you how do we use those expressions or those selection structures in real life applications. So let's go ahead here and have one of those logical operations. So I'm going to come here and put it this way, and line semicolon. Oops, what am I doing here? Okay, so I'm going to come here and say, and num1 is greater than num2, and I'm going to come here and put and num3. Let me change the values here. Put this one to be 2, put this one to be 7. I'm saying num3 is greater, or let's say less than or double equal num4. Okay, so let's look at this here. Cout, of course. Okay, so what do we have here? Well, I have two Boolean expressions. As you can see here, I'm highlighting them. And then I have the AND logical operator that connect those two Boolean expressions. So what's going to happen here? Let me just show you that. This is going to be evaluated to true and false, and this is going to be evaluated to true and false. And then the whole expression is going to be evaluated to a true or false depending on what is the logical operation that we have here. As a rule, this Boolean expression will be only evaluated as true if both ands here are true. Otherwise, it will be false. So if one of them is false, then the whole thing is false. If both of them are false, then the whole thing is false. Only is going to be true if both of those expressions are true. And let's see if that's the case. Well, num1 is greater than num2, so that's okay. Num3 equal num4, well, that's not okay because it's not, so this is false. So the final result is going to be false. Okay, that's AND. Let me copy this and go down. And what if I replace it with false? Well, let's put it here. Sorry, what if I replace it with the OR? If that's the case, well, the final evaluation for this expression will be true as long as one of them or both of them is true. What does that mean? It means if this one is true, then the whole thing is true. If this one is true, then the whole thing is true. If both of them are true, then the whole thing is true. It's only going to be false if both of them are false. And that's basically what you have to remember here. Now, let me show you something really quick. We have what we call a Boolean table or a logical table, and I'm going to show you how it works. So, let's imagine we have an expression. I'll call this one A, and I have another expression. I'll call this one B. And I have here A. Oops, my handwriting is really, really bad. I'm just going to type AND here. And B. Let me just write it here. So I'm going to use 1 and 0, just like how C++ like to define the true or false. So this is going to be 0, 0, and this is going to be 1, 1, and this one is going to be 0, 1, and this is going to be 0, 1. I'm here listing all the possibilities of a combination that could happen between them. Now, since I have AND operation, I know this for sure is going to be false because both of them are false. This is going to be false because A is false, and this is going to be false because B is false, and this is going to be true because both of them are true. Now, let me go here and put A or B. Okay, so here we go. Again, I'll get 0 here because both of them are zeros. Here I'll get 1, true, because B is true. Here I'm going to get true because A is true. And here I'm going to get true because both of them are true. Let me just try to write a line here. I just bought this pad, and I'm trying to get used to it. But I think I'm doing good. So this is basically the truth table or the truth table or Boolean table of the AND of the operation. Now, you don't have to remember this, of course, but if I would say you have to remember that if you're using AND, basically means both of them need to be true. If you're using OR, one of them at least need to be true. Again, I will show you a lot of examples later once we're done talking about the concept here. Now, we have what we call a short circuit. And now, what is a short circuit? A short circuit basically means, and this is extremely important to understand, I want you to look at this expression here. And let me just change this to be false. For example, num1 equal num2. Now, we know they're not true. Now, I want you to ask yourself this question. This is basically one of the optimization mechanisms used in C++. And by optimization mechanisms, we mean a technique that is used to make the process of executing faster. Now, I want you to look here. If I evaluated this expression here, and the final evaluation was false, does it really matter what is the evaluation of this expression anymore? Because this is false, if this one is false or true, the whole evaluation is going to be considered to be false. Now, since this one is false, then there's no need to go ahead and complete this comparison here. This is basically what we mean by short circuit. Again, it's not like you're going to use a short circuit, but it's basically something, an option that comes with C++ that you just need to be aware of, because a lot of people like to ask about these questions in interviews. So that's about and. How about or? Well, let's put, let's keep this one. Num1 is greater than num2. Now, if you look at here, that condition is actually true. So what does that mean? That basically means whether this expression is true or false, it doesn't make any sense or doesn't make any change. Because this one is true, that basically means the whole evaluation is going to be true, despite whatever the evaluation of this expression is. And that's basically what we mean by short circuit. Those two expressions are going to be evaluated only, for this case, if this one found to be true, then I have to go and check and see if the other one is true. Now, if this one was found to be false, then basically I need to go and check the other one to see if it's false and true to be able to evaluate the whole expression. And that concept by itself is called short circuit. This basically will simplify everything you need to know about Boolean expressions and how do we create them and what is the meaning of them and how do we handle complicated ones and how do we handle or use logical operations. Now we're going to be moving on to the selection structures themselves. Well, we basically have three main selection structures, and they are the if statement, the if-else statement, well, actually there are four, and there's the nested if statement, and then we have the switch statement. I'm going to go through them right now one by one, and then right after I'm done with that, I'll have a break and come back for an example about the whole selection structure, and I'll try to make it as simple and as easy as possible to understand. So let's start with if statement. If statement, basically, the syntax of it is you start with the keyword if, and then you must open a parentheses. And here's something I want you to pay special attention. Do not type a semicolon here. Do I have to sing it? No. Do not type a semicolon here. I've seen a lot of students doing this. This is where you lose 50% of whatever you're doing. Do not put a semicolon here. As you can see here, if I go back all the statements that I typed, there was a semicolon at the end. But with an if statement, do not put it. If you put it here, you're telling the compiler, this is the end of the if statement. Well, I'm not done with it yet. So you don't put an if statement semicolon here. Now, what do we do basically after that? For people who are just starting writing C++ code, I recommend to open a curly brace and a closing curly brace. Now, can I not use them? Yes, there is an option that you have if you don't want to use them, but I'm going to talk about that later. And then after that, in this area, between those two parentheses, this is where you type your Boolean expression. And I'm going to go ahead and use this Boolean expression. Let me just copy it. And I'm going to put it here. So here it is. This is my Boolean expression, of course. Let me just put some spaces here. I can take some spaces out. It doesn't matter. C++ doesn't recognize spaces. So for the compiler, they're all next to each other. Which something I can show you later, but I don't want to freak you out. So here we go. If, And I want you to remember this. If this expression return true, I want you to do whatever you have between those two curly braces. And look what I'm going to do. For example, I'm going to come here and create an integer. I will call it my data. And I'll assign 100 to my data. And then this doesn't make any sense. I'm just doing something. And then I'm going to go and show my data. And it's supposed to be uppercase data. So let's go ahead and fix that here. Data. And let's go ahead and line semicolon. So as you can see here, and let me just put, you know what, I'll just put here a cout, and I'll just type end, \n to go to the next line, and I don't need to use the end line here. Okay, so let's look here. If this expression is true, those two lines of code are going to be executed. If it's false, the compiler will escape those two lines and go to the end line. Now, let's give this a try, just for the purpose of it. You'll see that 1, 0, 0. Here it is. Let's just go back here. How many cout statements I have? Okay, here 1, 2, 3, 4. I don't care about the first 4. I care about those two. See, you see here, I got my data to be printed, which is 100, and I got the end to be printed here. Now, let me just change this expression to be false. For example, equal. We know it's not equal, so it should be false. And you will notice that the 100 is not going to be printed on the screen, and it's just jumped to the end. So this is basically what the if statement is all about. I have an expression here. If the whole expression here is evaluated as true, then this part is going to be executed. Otherwise, it's going to be escaped. Now, I said that those two curly braces, sometimes you need them, sometimes you don't need them. Now, in this case, I need them. Why do I need them? Because I have 2 lines of code. Now, imagine I have only 1 line of code. Let me just take this one away. I'm just going to convert it to a comment. We know that the compiler will ignore comments. I'm just going to put 100 here. Now, if I take this one away, and take this one away, the compiler will be okay, because how many statements do I have after the if statement? It's just 1. And then after that, since there's no curly braces, the compiler will consider that this is the body of that selection structure or the if statement. If you have multiple lines, just as I said before, then you need to have a curly brace so you can tell the compiler this is the beginning of the body of this selection structure and this is the end of the body of that selection structure. And let's just put my data back again. Now, as you can see here, this example here, the compiler only care if this expression is true, this is going to be done. But what if it's not true? Basically, it's just going to go with the normal flow of execution. It's going to go to the end, press, and now, what if I want my compiler to actually have 2 responses to that expression? If it's true, something's going to happen. If it's false, something else is going to happen. After that, it's going to go to the normal flow of code. So what I'm going to come here and type else. And in this area, I'm just going to go ahead and do cout test me out. And let's put a \n. So what's going on here? Well, here's the deal. This expression is going to be evaluated. If it's true, those 2 lines are going to be executed, and this one's going to be ignored. If it's false, those 2 lines are going to be ignored, and this will be executed. And since this one is false right now, you will notice that test me out is going to be printed on the screen. And here we go. So the question that you may ask yourself, when should I use this and when should I use that? Well, there's no right or wrong answer here. It depends on what type of application you're trying to answer here, or what is the problem that you're trying to solve here. Sometimes you only care if the expression is true. If it's false, just go with the normal flow of execution. Sometimes no, you want your computer program to go to 1 out of 2 directions. If it's true, go left. If it's right, go right. If that's not the case, then you just need an if statement. Now, we have what we call also the nested if statement. Before I get to the nested if statement, let me just ask you a question. Do you see this integer here? Integer data equal 100. Now, if I come here You know, let me just go back here. For example, if I have those num1, num2, num3, num4, and if I come here and type cout num1 and line. So as you can see here, this is just going to print whatever the value of num1 here. Now, let me try to do the same thing with, you see this cout my data? I typed it here in this area and there is no problems. Now, what if I typed it here? Look at this. I got an error. Now, the compiler, if you put the compiler, it says, look at this. I don't know if you can zoom or not, but it says, identifier my data is undefined. That basically means the compiler doesn't know what is my data. Well, here it is, my data. I just defined it here. And I used it here, and you didn't complain. So what is the problem? Why are you giving me a hard time here, telling me that it's not defined? Well, this is my next point, which is basically what we call the scope of the variable, or the lifetime of a variable. And let me just show you what do we mean by that. You see this main function here at the beginning? This is the beginning of a block of code, and this is the end of it. So I defined num1 inside the main function, and I used it inside the main function, so the compiler doesn't have any problem with that, and it was easy to recognize and work with. Now let's look here to the my data. Where did I define my data? I'm still inside the main, but again there is another block of code which is more specific associated with this if statement. So I declared the variable in this block of code. Let me just highlight it. That basically means when the compiler is going to execute the lines between those two curly braces, that's the only place you can actually use my data. It will work here. But the moment you leave, you get yourself out of this block of code, my data doesn't exist anymore. And this is one of the ways that C++ used to manage memory wisely. So basically, since I declared and defined my variable inside a block of code here, only inside this block of code I can use it. Outside, I can't. So what if I actually need to use it outside? Well, here's what I can do. If I cut it from here, and I defined it here, and let's put it here, you will notice that both errors are gone now. Now you may ask me the question again. Well, you just said that if you declare a variable inside a block, it's going to be available inside that block only. Well, here's the thing. If you have a block of code inside a bigger block of code, then if you declare a variable outside that smaller one, then you can use it inside it, but you cannot do the opposite. Now, this is one of the concepts that get students, especially those are beginners to this concept, a little bit confused. So this is basically what we mean the lifetime of a variable, or the scope of the variable. This is very important. This is a tricky part. This is where I play games here. I review a lot of variables. I declare them in a lot of different places, and I ask you if they're going to be an error or not, or is it going to work or not, or what is the final value of it. So you need to pay attention to where did I declare those variables and the lifetime of that variable, and am I using the variable in the right time, or I'm using it after it's dead? This is something to consider. Okay, so this is if statement. This is else if else statement. We have what we call a nested if statement, and I'm not going to show you a real. Well, you know, let me just go ahead and show you an example, and then I'll show you a real life example of how do we use the nested if statement. Oopsie daisy. The nested if statement is very simple. You come at the beginning here and you type your if statement. If 10 doesn't equal 10, which is false, as false. So I am not going to write multiple statements. I'm going to keep it simple. I'm going to come here and say cout. And I'll just type ABC and line, semicolon. And here I'm going to type else. And what I can do after that, I'm going to put an if statement here. That's very important. And then I'm going to come here and put another Boolean expression. And I'm going to say, for example, 7 is greater than 8. And here I'm going to come here and say cout, Again, this example doesn't make any sense. I'm going to show you a real example later. Just work with me here. In this case, I'm going to put B, 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 C, F. Okay. Now, let me put another else. If I'm going to put 5 is greater than 3. And then C out. And then I'll just put U backslash N. And put semicolon here. And finally, this is very important. A lot of students forget about this. Else, C out. J backslash N. Okay, so this is an example of what we call a nested if statement. So you got if and you got else. After the else, you got another if statement, and for this if statement, you have this else, and then after that, you have another if statement, and it has an else by itself. This is a nested if statement. Why do we do that? Why do we go through this? I'll tell you one example, and I'm going to show you how do we do it later. Let's imagine I want to convert your grade from the numerical value to a character. And let's say you can have an A plus, you can have an A, you can have A minus. Is there any A plus? I'll consider there's an A plus. A minus, and then there's the B plus, and there's the B, and there's the B minus. And you know where I'm going. So what we do basically, we check for the highest grade at the top. Did that student get an A plus? If he didn't, we go after that, we check if he get a B plus. Oh, sorry, A. And if that's not the case, we check for an A minus. And if that's not the case, we check for a B plus and B minus until you get to a person who got a D or an F. This is basically an example of where do we need to use this nested if. So how does it work? Well, basically, if this condition is true, this is going to be compiled and executed, and whatever you have here will be ignored. If this is not true, you go to the second if statement and you evaluate. If this is true, then this is going to be executed and everything here is going to be ignored. And then you go to the next one, which is this part. If this is true, then this is going to be executed and what else you have here ignored. If everything is false, then basically you will get to the default case, which basically is going to be the JJJ in this case. Now, this here, this expression, and I've seen a lot of students, because they don't understand this very clear, they go with this technique. And I want you to pay attention here. They take this else away, and they take this else away, and they take, well, I'll keep this else here. Now you may ask a question, what is the big difference between this and this? I'll tell you what's the difference. Different is, here, if this expression is true, this is going to be executed, and all these 4 lines or 6 lines are going to be ignored. Ignoring lines at execution basically means saving time. Now let's look here. If this is false, the compiler is not going to ignore those. It's going to test for this and test for this and test for this. So basically, if you just go use if statements without nested else statements, you will end up basically checking all these expressions, and that could lead to a delay in the time. So that's why an if statement else statement is your good choice. Now, if I use this, is that wrong? Well, the compiler will be able to execute it, but again, it's not the most efficient way to do it. That would be number one. Number two, some cases, no, this will not work, and this will work. Right now, I don't remember, but I remember one time there was a case where this wasn't the case. You could not use if else. You need to check everything. Like the example that I told you about the grades, a student will have one of those grades, A plus or A minus or A or B, but you don't have to check for all of them. Once the student was checked for an A, then he got the A, and that's it. There's no need to check the other ones. But let's say I have, let's say it's a patient that goes to the hospital, and I'm trying to diagnose that patient and I have multiple tests. Well, yes, if that's the case, just because he have a fever, that doesn't mean necessarily that he's okay and he doesn't have any other diseases. So I need to do a test for everything. Whenever you feel like your application needs to do a test for everything, then basically this else statement doesn't work anymore. So let me take this away. I just want to say something here. I'm sorry for my videos that are way too long, but again, I've seen a lot of short videos that people make, and I feel like they always leave me with a lot of questions. So I'm trying to make them as short as possible, but I'm trying to cover as much as possible. So we talked about the if statement, the else statement, the nested if statement, and now we're going to talk about the switch statement, and that will be the end of it. Let me see. That was not that long. Okay. Now before we talk about the switch statement, I need to explain something that is very important, and we're going to use it a lot later in the future. But since it's part of the switch, so we need to have an idea about it right now. We have a special data type that, I'll call it data type for now. We're going to use the right term for it whenever we get to that point. But I can come here and do this, and I want you to pay attention. Enum. It's a keyword. You can see that it's blue right now. I'm going to call it color or colors. And then I'm going to open a curly brace, and here I'm going to put red, green. Of course, you don't have to put them uppercases, but it's known in C++ that we use those uppercases. Blue. If you choose not, that's still okay, but it's recommended to go with uppercases so people recognize, oh, you're talking about enum here. Red, green, blue. What else I want to put? Yellow. I'll just keep it simple. And here we go. I'm done. So what is this enum thing? Well, let me just try to find a way to explain it. Sometimes in life, you have, this is not string, by the way, just to let you know, but we have some terms that are associated with numbers. For example, January is always associated with 1. February is associated with 2. March is associated with 3. So each month is associated with a number. Now, this structure here is a perfect, or it's good to use with names that we always associate with values. Now, how do I use this? Well, this is enum data type, so I'm going to come here. What did I call it? Colors. So let's go ahead and come here and go down. Put colors. That's what I called it. And I'm going to call it my color. And then after that, you have to give it, not double quotation. You have to assign a value, one of those values here. So for example, I'm going to go with blue. Now, look what I'm going to do. I'm going to come here and say cout my color. C. And I'll put an line here. Now, we need to understand. Now, I'm trying to show color. What is my color going to be shown when I'm trying to use it in expression, use it in calculation, or use it to show something on screen? Here's how it works. Each one of those colors that I listed here is associated with a value. Red is associated with 0. Green is associated with 1, blue is associated with 2, and yellow is associated with 3. So when I ask the compiler to show me my color, it's going to go and show me the value associated with blue. So let me just run it. And just look at the last printed element after the end and press. Here it is, 2. So this is basically what we mean by enum. Now, what I can do here, let's say I don't like the way that it starts with 0, I can put 1 here. And if I started with 1, that basically means there's going to be 2 and 3 and 4. Let's run it, and you'll see that instead of 2, it's going to show me 3. And here we go. Now, what if I don't like those numbers? Let me start with -3. So this is going to be -3, -2, -1, and 0. And you can see -1. Now, what if I don't like the fact that they come in order? For example, I'll put 77 here, and here I'll put 90, 980, and here I'll put 76, and here I'll put 12. Well, whatever the value now you decide to assign or associate this enum data type with is going to be shown on the screen. So let me run it. And you see that's going to get 76 here. Okay, so I hope you guys get an idea. Now, I'm sure you're asking, what is the whole point of this? Well, I want you to think about this. In some applications, you have a list of items, and every single item is associated with a value, a data. So instead of just creating a variable, instead of creating, that was my phone, instead of creating a variable and assign a value to it, we can actually do it this way. And especially that all these values you can see here, they fall under one concept, which is colors, which basically makes it a lot more sense to go with. I can create day weeks, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and all of that. I can put them there and then assign values to them. I can go with months. I can go with whatever you can think about. You can get it done, and you have full control over it. Now, why do I mention this here? Because switch use enum at a certain point. So I'm going to keep it as it is here. And let me take those values away. Let's just put =1 and then start from that. And I'm going to take this away. Imagine yourself having a company that makes colors, painting colors, and you have a color code for each color. So you can create an enum for that. And you can list them, and it will make it a lot easier to have access to them using the name that is associated with the value. Maybe the price of that color is associated with that value that you have here, so it makes it a lot easier in calculation. Now, let's go ahead and talk about switches. What is a switch? And let me go back here. Now, before I get to a switch, let me go back to the if statement and talk about something. This if statement here that you see, that is followed with a Boolean expression. It's more like I'm asking you a question and I'm expecting an answer from you, and that answer is a true or false, yes or no. Is this expression is true? Yes. Is this expression is true? No. Evaluate this expression, it's true. Evaluate this expression, it's no. So the final feedback or the final value of evaluation of those Boolean expressions, it's always true or false. Now, what if my scenario is not a true and false case here? I want to make a decision based on another case. For example, how many apples do you have? So, if you have 1 apple, I will ask you to do an action. If you have 2 apples, I want you to do another action. If you have 3 apples, I want you to do another action. If you have 5 apples, I want you to do another action. So I have multiple actions associated with different values. So it's not a true and false, if you will. The question that I'm asking you, how many apples do you have? And you're going to tell me a number, and based on that number, an action will be taken. This is where the switch will be a good choice to go with. Now, one thing you should know, very important, mostly, and I can tell like 99.99% of the cases, you can use a switch and you can use a nested if statement and you will get the same results. But sometimes a nested if statement is going to be way more complicated than a switch statement when it looks at the code itself. So you can put it as a rule. If you're asking a question about something and you know that the final answer is going to be true or false, then you go with an if statement. But if you're asking a question that you know the result is going to come back as multiple possibilities, what's your grade in the exam? It's A, it's B, it's C. See, there's multiple answers. It's not a true and false, yes or no. It's multiple different answers. That's where a switch is a good choice. How many phones do you have? I have 3. I have 2. How many cars do you have? I have 1. I have 2. I have 3. How many kids do you have at home? I have 5. I have 10. I have 16. And so on. So you can see that if I'm asking you a question Are you 32 years old? Yes or no. That's an if statement. How many rooms do you have in your home? You're not going to say true or false for that. You're going to tell me a number. So that's where the switch will be a good choice. So I don't want to keep going in that, but let me just go ahead and work on it. I'm going to use this example later, but let me just start with an integer num x equal 10, semicolon. So I create a new variable, I call it num. Now what do I do here? I type switch. The syntax is a little bit longer than the if statement. And here you put num x, just like that. You can put a numeric value here. You can put some expressions that's going to be evaluated to true or false. That's not, if you're going to have a Boolean expression here, just go with an if statement. But I can have, for example, a plus b, which basically can return 10, 20, 30, 40, a number. Now, after you do that, this is very important, you type case. And now you put the value that you think num x will be equal. So, for example, 1. And I will have another case. Let's say 2. Let's have another case. 10. And you can have as much cases as you want. Now, after you type the case and a colon here, just remember, you tell me what do you want to do if num x was 1. Well, I'll just go ahead and type cout hey \n. I promise you, all this nonsense that you're seeing, I'm going to give you a real life examples later. Cout, and I will say you. That's what my wife uses with me a lot. Every time I made a mess or something. And that's my case. How about 10? Cout PS4. Why? I don't know. Semicolon. So, here we go. This is my situation. Am I done? Nope. Basically, I still have a lot to do. I'm just going to give them a really nice tap here to understand that this is a block of code. Now, what am I doing here? Basically, if num x equal 1, what's going to happen here basically, you're going to use num x, which basically is 10, and you take that 10 and you compare with all these cases. If you find a match, then whatever you see after the colon is going to be implemented. So 1 doesn't match, 2 doesn't match, 10 match, so you'll get this implemented. Now the question is, what if I have 4 here? Well, there is no match. If you don't have match, it's always recommended to have what we call a default case. And a default case, basically, you just come here and say cout. And let me close this. No match. \n. Am I done? No, I'm not done. There's another thing you have to add here, which basically a break statement. So you come here and add a break statement at the end of each case. Now, of course, each case number of statements doesn't necessarily have to be just 1. It could be as much as you want. But I'm going to show you an example, a good example actually, later after I'm done. The default doesn't need any break statement because it's the last one. You can add one if you want, but again, that's just going to be redundant. There's no need for it. So what's going to happen here? Basically, if I found a match here, this is going to be execute and break. Break means leave the switch statement. You'll find your match. Get out of here. And again, if this doesn't match, then you go to the next one. And then if you find a match, you do this and then leave. You keep going that way until you are done. Now, the last part I want to talk about here, what if I want to do the same action? Let's say I'm going to copy this. And I'm going to go down here. I'm going to put case 5. So basically what I'm saying here, case 4 and case 5 basically have the same action, which is showing PS4. If you have a case like that, multiple cases that share the same action, well, there's no need to redundantly type that. Just come here and type case 5 and take this away. That is totally normal. Some people like to put them next to each other, case 4, case 5. Some people like to put them underneath each other. It doesn't matter. You can do it the way you want. So as you can see here, this is a switch statement. This is how it works. Now, some points that I would like to mention here. What I can put here? Well, you can put integers. You can put characters. You can put enums. That will work. That's not a problem. You cannot put float or doubles here. You cannot put strings here. That's not recommended again. So you can only go with integers, characters, and enum. How do we use enum here? Well, let me just try to do that, and that will be the end of this part. And I'm going to come back later to show you some examples. So switch and open a curly brace and go down. And here I do have my color in this area. And then I'm going to come here and type case. And instead of 1, I put red. And now, sorry, I hit the speaker, the microphone. Case. What kind of cases do we have? Green. Let me copy them from here. Now put it here. So case green. Rachel green. Case blue. And case yellow. And of course, don't forget the default case. And now you decide whatever you want to be happen in this area. So I'll just go ahead. Maybe you want to show the hexadecimal value for these colors. So let's go ahead and do that. What is the hexadecimal value for red? It's red, green, blue. So 0xFF00. Now, if you don't understand what I just did, don't worry. You probably will learn about that later. But this is basically what red look like inside the memory system, or how it's stored. So break, remember. Now I'm going to copy this and put it here. And this is going to be 00FF00. So because, let me just go back here, red, green, blue, and this is going to be blue. So there's going to be 000FF. And yellow. How do we get yellow out of colors? I think it's red and green. I don't know. I'm just going to put something here. Red and green will give me yellow. I know it's not true, but I'm just going to assume that's true. And then default. Remember, there's no need for this break, so I'm going to take that away. By default, if none of the colors are used, you can choose to go with black, or you could go with white. If you go all FFF, that's white. If you go all zeros, that's black. And that's it. Now, since color, I decided that it's going to be blue, so I'm supposed to see this one printed on the screen. Let's go ahead and run it. And as you can see here, it's blue, and the other one, there's no match for the cases that I had here. Where is it? 1, 2, 4, 5, and there is no match. Now let me just put 10 here, just to show you that if there is a case of match. And here we go. Okay, so this will be the end of this part. In the same video, I will come back with an example about how do we use the switches statement, the if-else statement, and Boolean expressions, a little bit more complicated ones. In this part of the video, I am going to I'm going to actually have an example about how do we use the selection structures. The question is asking you to ask the user to enter 3 integer values, and then a list of, or a menu is going to be shown after that for the user, asking him to choose one out of 4 options. Each option basically represents an operation that's going to be applied to those 3 values. So the first option is when you try to find the smallest value, and the second one where you try to find the greatest value. Greatest. This is not how you type greatest. And the option number 3 is basically adding all these numbers together and printing the results. And option number 4 is to multiply the first 2 values and divide them by the third value. Divide the results by the third value and then show the final results. Okay, so of course the user may make a wrong choice here, so we need to have a case just in case the user decided to enter a value that's not 1 or 2 or 3 and 4. So how do we get this done? Well, let's start by creating those 3 variables, integers, that we're going to actually ask the user to enter them. So I'm going to start with integer. I can go with val1, val2, and val3. It's always recommended whenever you create a variable to initialize it with a default value of your choice. I'm going to go and choose 0. Okay. Now after that, we need to ask the user to enter those values, so I'm going to go ahead and do that. Cout, and I'll just type enter 3 integer values. And I'm going to let the user enter those values in the same line. So cn, we'll just type val1, val2, and then val3. Okay, now that I'm done entering those 3 values, and of course I need to actually include or using the std for cn because I didn't have it here. Let's go ahead and do that. Cn semicolon. Now that I'm done with this part, now we need to go ahead and show those choices to the user. And then we're going to have to ask the user to enter a choice here. So I'm going to come here and say integer user choice. And I'm going to assign this to 0 at the beginning. Now all I have to do is to show a cout, and I'm going to show those messages. First of all, we're just going to ask the user the question, please make a choice. And then before, make a choice out of the following. Okay, so we need to actually show those choices to the user. So cout, again, most of the time I'm trying to communicate with that user, so I'm going to show him those 4 options. Let me copy this. You know, let's just make them one by one. Copy that and put it here. And put \n, so it goes to the next line, and put a semicolon here. So option 1, and then let me copy this, put it here. Since we have 4 options, I have to show these 4 options. Already got 2 of them, 1 of them, sorry. Now I need to go and show the other 3. So cout. Okay, let's go back here, and we'll go option number 2. And I'll go paste, \n, semicolon, and in this area we'll show option number 3. Just put it here, and \n, of course, semicolon. And finally, option number 4, which is going to be a little bit longer. I'm going to try to make it a little bit shorter. So this is, for example, this one, add the 3 numbers. I'm just going to keep it that way. Of course, I'm going to show it on the screen. And option number 4, multiply the first 2 and divide the result by the third value. Let's take this away, push this up, and it's missing the and line here, and a semicolon. Now after the user will be able to see those options, then I'll just put a \n here so I will have them printed underneath each other. I'm going to come here, I'm going to show another message, cout, just to remind the user that he should choose 1 or 2 or 3. So I'm just going to go 1, 2, 3, 4, and I'll put a question mark, space, semicolon. So he needs to make a choice out of those 4. I'll go cin, and we have a variable called user choice. So until this point, the user basically will need to make a choice. Let's just give this a try. Before we continue, this is again something very recommended to do. Do not wait until you get the whole project done until you test it. Just test it as long as you go with the process. Every time you feel like you accomplished a percentage of your project, give it a try, give it a spin, and see if it's working fine. Of course, again, we're going to have to wait a little bit. I don't know why it's doing this. Your device needs to restart to install updates. Okay, we'll do that later. Please enter 3 numbers, 12, 23, 34. And here it is. Please make a choice. Oh, I forgot to put \n here. Option number 1, number 2, number 3, and number 4. And then as you can see here, you make a choice. I'll go with 2, of course. Nothing's going to happen, and I'm done. Let's go ahead and fix this. I'm going to put \n here. That'll be number 1. Number 2, there's no need for this end line. I'll keep this here. Because I have the cin here and I have a get character here, I probably will have to cin ignore. Put semicolon here and put 1. cin.ignore, I think that's what it is. No, try to remember. Yep, here it is. Let's give this another try. Hopefully this will fix everything. So I'll go again, 12, 23, 34. Please make a change. I need to put this back. Option 1, option number 2. I'll go with 2 and then press it. Okay, everything works just fine. Let me take the space here away. Okay, so let's keep going. What I'm going to do here, since I have a menu and the user is going to make a choice, basically the user could make a choice with 1 or 2 or 3 or 4, or you can enter a value that's not one of those 4. So I can answer or solve this problem using a nested if statements, but it's going to be very complicated. This is a perfect case for a switch. So I'll go switch. You open a parenthesis and close it. Have a curly brace, and you put user choice. And you go ahead and put it here, user choice. Now, I do have a case 1. Now I'll have a break here, semicolon. Let's enter all the cases and then we'll talk about the implementation. And this is case number 2. And then we have case number 3. And then we have case number 4. Now, if the user entered any of those 4 values, then we will have a case for them. But again, the user may decide default, and that's the default case. Now I'm just going to go ahead and do the default. I'll just go invalid entry \n. So here we go. I'm just going to show this. Now, if you go back to the options, option number 2, 3, and 4 are easy. I can go ahead and do that directly. And for 3, I'm just going to have to add them all together. So I'm going to go cout. I'll just type the sum equal, and then put a space here. And in this area, let's just go ahead and add them all together. So I'm going to copy those, go down and change a little bit. So let's just open parenthesis and close it, and line, semicolon. In this area, we're going to add val1 plus val2 plus val3. So let's take this away, put a plus, and then take this away and put a plus. And I'm done. That's basically what I'm doing here. I'm trying to find the summation for this. Now in this area, I am just going to say the results, cout, the result equal, yes, let's say here, I'm going to come here and say this, and then end line. What am I supposed to do? Let me copy those and put them down. I'm just going to update them here. First of all, where's the paste? Here it is. I'm supposed to multiply those 2 values together and then divide the results by 3. Now I have multiplication and I have division. They basically have the same priority when it comes to which one of them is supposed to be executed at the before the other. And if you have a case like that, the compiler will basically go with the one to the left and get them done, and then divide them by the third one. If you want to buy some insurance, if you are not 100% sure about how the acting of the compiler will be, this is a case that could happen if you're teaching multiple programming languages or you're studying multiple programming languages and each one of them has different set of rules. So you're just buying insurance, or you can tell the user that those are supposed to be multiplied first and then divided by 3. Now just remember, those 3 numbers are integers, so the result is going to be an integer, so you may not get a correct answer. And by correct, I mean a number with fraction decimal points. So those are the first 2 options. Now option number 2 is basically when we try to find the smallest value. Now how do I find the smallest value? Well, the smallest value could be val1, it could be val2, it could be val3. So here's what I'm going to do. I'm going to check if, now look what I'm going to do here. Val1 is smaller than val2. And then I'll put and val1 is small. Oh, this is greater, my bad. I'm supposed to put smaller or less than. Val1 is less than val3. If that's the case, then we'll just go ahead and do cout, and we'll type val1 and go end line. So this is my first case. I assumed that, and let me just put here 3 integers, integer value. I'm just going to put no equal values are allowed. Okay, this is just to warn the user from entering 3 different values. Actually, I could go ahead here and check and see I'll do that later. Let me just continue with whatever I'm doing here. Now, if that's the case, if val1 was smaller than val2 and val1 is smaller than val3, then that basically means val1 is the smallest. Now, else, I don't think this is the more efficient way to do it, but I'm just going to go ahead and do it. I could come here and say if val2, no, I'll just keep it this way. I'll think about it later. Now I'm going to assume that maybe val2 is the smallest value. I am 100% sure there's a more efficient way to do this, but I'm just going to, it's kind of 11 p.m. right now, and I am super sleepy. So now what if val2 is less than val1, and then val2 is less than val3? Well, that basically means the smallest value is val2. Let's copy that and put it here. And we'll put val2 now. Well, if this case is not true and this case is not true, what is left? Val3 is the smallest value, so I don't have to even check. Else, you go down here and you show me val3. And let's put val3 here. Okay, so this part is how I found the smallest value. I'm checking if the first one is the smaller than both of them, then it's going to be shown. Otherwise, I'll check for the val number 2. If I pass those two tests, so val1 is not the smallest and val2 is not the smallest, so whatever is left is which is val3, that's the smallest. Well, here I'm looking for the greatest, so let me just put here, I'll just say smallest value equal, and I'll put something like that. That makes sense. So let me copy this, put it here, and then put it here. One of those cases is going to be true. Now let me copy this and move to the case number 2, which basically I'm looking for the greatest. Well, this is going to be very simple. All I have to do is to replace this with greater. So val1 is greater than val2 and val1 is greater than val3. So it's going to be greatest. Why did I spell greatest here? Let's go ahead. Greatest. Okay, so greatest, and then we do the same thing here. Greater than, and then this is going to be, let's copy this, put it here. And if this case is not true, this is not true, basically the greatest is going to be val3, and put it here. Okay, so I have case 1 covered, case 2 covered, case 3 covered, case 4 covered, and a default case, of course, if the user entered something that is not valid. I do have one thing I want to do here, is when the user finishes the process of entering 3 values, I need to make sure that none of those values are equal. If that's the case, something is going to happen. So here's what I'm going to do. I want you to pay very special attention to what I'm going to do here. As you can see here, it said no equal values are allowed. So what if the user actually did enter 2 values to be equal? Well, the program is just going to show an error message and it's going to terminate itself. So here's what I'm going to do. I'm going to come here and say if. We do have a lot of possibilities that we are going to cover here. Let me tell you what is not acceptable in C++. You cannot come here and type this. Equal, 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 equal. This is going to be a problem. The compiler doesn't accept this here. I have 3 equal operations basically, and this is not recommended. Even though it's not showing any errors, but it's not recommended to do it this way. So what I'm going to do, I'm going to say if val1 equal val2, or, let me just copy this, val1 equal val3, or val2 equal val3. Equal val3. This basically cover everything. Even if the three of them are equal to exactly the same, then this is going to be true, and this is going to be true, and this is going to be true, which basically means we just need one of them to be true for the whole thing to be true. So I'm saying if the first one equals the second one, or the first one equals the third one, or the second one equals the third one, either way, this is what I want to do. Cout what did I said. What did I say? What did I say? No equal values are allowed. I'll just copy that and put it here. \n, and this will be the end of the program. Now what I'm going to do, and look at this, I'm going to come here and type else. That basically means the user actually entered everything correctly. So if that's the case, I'm going to keep going with the program just like a normal way. So what I'm going to do, I'm going to come here, select everything that I have here, and I'm going to give it a push. And then this is it. This is the else case where basically they are all not equal. I need to come here at the bottom and close that else statement. So you can see here I got a really long else statement here. So if the user entered two values that are the same, an error message is going to be shown, and the program is basically going to jump into press any key to exit. Now if the user didn't enter values that are equal, so basically this is going to be skipped, and the compiler will jump into this portion of the program, this part of the program, and keep going normally. So we need to check all these possibilities. I'm going to start with the first one, which I'm going to enter two values that are exactly the same. I'll go with 2, 6, and 2. Of course, where is it? Where's that ignore? Where did I put it? Here it is. Let me cut this. I need to put it here. Control V. Oh dear Lord. Where is it? Here it is. Cut it. Now let's run it again. Okay, so here we go. 2, 6, 2. What did I say? No equal values are allowed. And the program terminated. And of course I can go 1 and 1 and 1, and I'll get the same message. Okay, so it looks like that's not a problem. Let's go ahead and put two values that are different. So I'll go 12, 23, 34. And now I'm going to have to go in with a choice. I'm going to enter something invalid, 9. Invalid entry, press exit to. Okay, so that case worked, 12, 23, 34. I'm going to look for the smallest value, which is supposed to be 12. So I'm going to go with 1, 12. Let's go ahead and do this again, 12, 23, 34. Let's go and look for the greatest value. That's 34. Let's try to add them all together. 22, 33, 44. Choose 3. Well, that's supposed to be 77.99. I believe so. Yep. Here we go. And finally, let's go ahead with the addition. What I'm going to do here, I'm going to put 2, 5, and 2. No, not 2. Let's put 3. So 2 multiplied by 5 is 10. 10 divided by 3 is supposed to be 3, and a lot of 3s point a lot of 3s. So if I go with option number 3, oh sorry, 4, it's 3. That's because it's division, integer division. And that will summarize everything. So here we go. This is a case, this is a code where I created a menu. I asked the user to enter values. This is basically how we create calculators to start with. Instead of option 1 and 2 and 3, you can have multiple options, a lot of more options you can add to this. And as you can see here, I use the switch statement, and I do inside these switch statements, I have an if, nested if statement, and also I had a very big main if statement here to check if the values are equal or not. This will be the end for this video, and it's going to be the end for my day. I need to go sleep, and I'll see you guys in the next video.